Okay. Wow. All right. Good morning again, everybody. All right. Take a few minutes to work on your If My Bones Could Talk. But before you start working on that, and I probably should wait a little longer to say this to everybody because we still have quite a few people not in yet. And again, I appreciate you all for being on time. Wonderful people that you are. So early in the morning on this cold day, I know you'd rather stay in bed where it's warm. But and as I was going through the topic of the day, this is a strange topic to start your day with, but here we are, forensics, first thing in the morning. All right. The activity with If My Bones Could Talk. The couple of the ones that I've read so far are just giving me general information. I had one, Shaylin, and I'm going to share that with you all as soon as she joins class because I want her permission. But you are supposed to reflect on yourself. And so it should be describing what's happening with you and not just general information. So if you tell me about, um, they can tell if it's a female. How do they know you are a female? Describe why they would know. Don't just say you can tell that the body is a female because of yada yada. Tell me why they know it's a female. This is kind of, looking at your resources that you've studied so far. What do you know about the bone structure of a female that is different from a male? How would they know you're female, not a male? How do they know how tall you are? So yes, it can tell your age. Yes, it can tell your height. How do they know how tall you are? And tell me how tall you are. It'll say the bones will tell them that I am such and such height. It'll tell me that somebody put in that it'll give you your ancestry, and they left it at that. What is your ancestry? What did it tell the bones tell us about your ancestry? So, because some people were having trouble of trying to make it 250 words. The person that I looked at that I want to share with you, she had 271 words. So it's possible to describe you in 250 words. Okay. So take a few minutes to, I'm actually going to give you a few minutes to work on that this morning before we start um, rigor mortis. If you've already submitted yours, um, you can look at the page in Canvas on rigor mortis, alga mortis, and all those mortises. And we'll get started with that in a little while, but I want to, um, where'd it go? Okay, there you go. So I got about 5, 6 people who've already completed this. Like I said, so I'm gonna wait another minute. So work on that for a few minutes. If you like, again, if you've already worked on um, submitted yours, and you know I've graded it already, um, look at the module on alga mortis and rigor mortis. And that's what we're going to address this morning. It's HRI, postmortem changes, rigor mortis, and alga mortis. That's where read that over. It's a uh, very intense page. But again, if you have not submitted your essay, and it is due today, I remember we're staying on top of our assignments, making sure they're all on time. Give it a look over and see how you can add more personal information. Remember this, they are looking at you and they want to be able to say that it's you and not your neighbor. It's not your sister. Remember how we watched one video where the father lost his whole family, but one of the two of the family members were twins. How did they tell the twins apart? So think about things like that. But again, this is about you. Make it about you. If I am the forensic anthropologist, how am I going to know it's you? All right, we're going to take 10 minutes, 10 minutes. And then I'm going to go on with today's lesson. And if you've already written yours, go back and kind of, you may not repost it, but you can if you want to. But go back and see how you can adjust it so that it is more descriptive of you. Okay, this is second semester now. We're needing you to be more descriptive, no general um, quick, fast answers, because quick, fast answers are going to get you a short grade. So give it some thought. All right. Okay, just a second. Um, let's see. Let me I haven't opened GoGuardian yet, so let's see if that helps. All right, GoGuardian is now open. The video should be embedded in, it's an approved video, and it should be embedded in, okay, yeah, I didn't have GoGuardian on. Sorry about that. I had it up, but not on. Okay. All right, so again, everybody should be doing something. If you're not working on your assignment, which is due, you are looking at your Canvas page, because that's a lot of reading. That's a lot of vocabulary. While you're doing that, I'll post the attendance. 10 minutes, so 8:50, we'll get started. Jonathan just came. All right, good morning, Jonathan. We are making sure that either your If My Bones Could Talk is submitted, or you are working on the rigor mortis algor mortis Canvas page for the next 9 minutes now. 8:50, we're going to start the lesson, today's lesson. Still missing quite a few people. All right, Kenzie, you're off camera again. Um, I wonder if any of these folks are 10th graders. I know their PSAT is today. Oh, nope. Mm, okay. Good morning. Good morning. Good morning. Good morning. All right. Shaylin, I was just bragging on you that you wrote a very, very good. Yes, everybody's working on trying to perfect their um, If My Bones Could Talk assignment, but yours was excellent. And I'm going to share it with everybody if you don't mind. I'm gonna give everybody a chance to finish theirs first. So you got 2 more minutes to work on this, and then um, we'll share. I will share hers, and then we'll go on to talk about rigor mortis and algor mortis. So again, if you are already finished, you should be reading your page on rigor mortis, algor mortis, and decay. We might get to the next page about decay as well. Wow. Mm, right. Thank you, Addison. That was very good as well. Okay. So, okay, so I've also seen two more that were very good, but I'm still going to share this one just to give you an idea. For those of you who are still working hard. Sometime today. Okay, that's what I want to do. All right, so I want to share this one very quickly and then we'll go on. Instant, I see some of you have actually listened and added some things to yours. All right, so this one, um, as you can see, says, if my bones could speak, this is what they would say. I am a 17-year-old female that is 5'1". So again, identify the sex, identify the height. Age is determined by the skeletal material and the medical imaging. So they gave me, how am I going to figure this out? Okay. Not only how, how old you are, and then stated how old, if because I would need to figure out what the age is. And so some of you are just telling me, it would tell me how old I am. I I need to know how old you are. So I need to be able to determine an age. So how would I figure that out? I'm going to do some testing. All right, gender is established by examining the size and shape. There are distinct differences between males and female bones. For height, they might measure the length of my bones. That was something we saw in the video, how they measured your femur. The forensic anthropologist would also see when I was about 7 or 8 or broke my pinky finger. So that was something that would distinguish you from somebody else, a broken pinky finger. Okay. I would see that inspecting the body for fractures, doing x-rays, CT scans, so that she's telling me, how am I going to figure this out? Okay. The forensic anthropologist would also see the braces on my teeth uh, by viewing the alignment and pattern of the enamels on the braces. What are your teeth going to tell you? Some of you noted that it could tell you what kind of food you eat. Did you have a good diet or a bad diet? What are your teeth going to tell me? Okay. Forensic anthropologists would also see that I wear a size 4 shoe. Again, what size shoe is important? Measure your feet. And let me I'm just going to skim a little bit. Weight, and then it also could give you some weight. Inspecting the bone mass. Usually on bigger individuals have rougher areas around the muscle attachment. The forensic anthropologist would also identify a short, stubby nose and analyze the nasal and root tip on the nostrils. Now, a lot of times all of the nose structure, because your tip of your nose is not bone, it's cartilage, so that may not still be there, but depending on when they find the body, they'd figure that out. Forensic anthropologists would also see that I had mouth surgery when I was 15 and the lower jaw is fixed by as some of the teeth were removed. So that was a very complete and very descriptive. So I thank you for that. All right. That being said, those of you who are still working on it, see if you can um, make sure that you are as descriptive as possible. So go we're writing these assignments, try to be as descriptive as possible and incorporate the things that you are learning in the course. That's the point. It's not just a story about you. It was also supposed to incorporate some of the things that we are learning. And like I said, I've been trying very hard now to make sure that the videos that I show are not just embedded in the class video, but also I try to upload the video to the class section as well. All right, that being said, we are going to watch a video. All right, so the section that we're covering today is
looking for a way to stretch the dollar? With Insurify, you can cut your car insurance bill in half. Getting a deal.
Okay, skip the commercial. Okay. All right, let me get this shared with you. I think I got the sound checked off. All right, and take some notes while you're watching this.
Imagine that you're watching your favorite crime drama show. A murder has taken place. The police and forensic experts are looking for clues to catch the killer. One of the most important clues to solving the crime is determining when the victim died. The expert looks at the body, checks the body temperature, and examines the body's position. After a thorough examination, the expert then states the approximate time of death. The question is, how does a forensic expert calculate the time of death? The time of death is not the exact time that a person died. It is instead a time frame in which the person could have died based on the evidence presented. Forensic scientists calculate the time of death using many techniques. Their first go-to method is to study the physical changes that happen in the body after death. So what are these signs? There are 4 post-mortem signs that tell a great deal about time of death. These are physical observable changes that occur in the body in the first 24 to 48 hours after the heart stops. Your favorite crime drama.
I'm sorry. What I was really trying to do was to get this screenshot. All right, so I want you to make sure that you have that there are 4 different indicators. Let me see if I can't shrink this screen, get this screen to be a little bit, as the caption is not showing so good. All right, maybe it's my computer. All right, it's a little big, but we'll get there. All right, so let's get back to right there.
Is calculate the time of death using many techniques. Their first go-to method is to study the physical changes that happen in the body after death.
Okay, so that I want you to make a note of that. Okay, the first step is to study the physical changes that happen in the body after death. Because the question is always, what do we do first?
So what are these signs? There are 4 post-mortem signs that tell a great deal about time of death. These are physical observable changes that occur in the body in the first 24 to 48 hours after the heart stops beating and the nervous system shuts down. The first sign, pallor mortis.
All right, so you're gonna write that word down.
As the heart stops beating, the circulation of blood throughout the body decreases.
All right, so you can just write that part. After the heart stops beating, the circulation of the blood decreases. So that's a telltale sign right there. And remember, this is happening in the first 24 to 48 hours.
The organs farther away from the heart, like the skin, stop receiving blood. This gives a corpse the pale, lifeless appearance that we associate with death.
All right, so, and you might want to do this as a chart. Let's do this as a chart. So you have what the effect is, what is it, and then what are the signs that you will see on the body. So the corpse will have a pale, lifeless appearance. That's all you need to write. Effect, pale, lifeless appearance.
This paleness, which appears 15 to 30 minutes after death, is called pallor mortis. It is one of the first identifiable signs of death. The second sign, algor mortis.
All right, second sign.
Humans are homeothermic, which means that we maintain a constant internal body temperature. This constant average temperature is maintained by balancing the heat produced in the body with the heat lost. The circulatory system is an important mechanism by which humans maintain an average internal temperature of 37 degrees Celsius. Heat is produced primarily through the various metabolic reactions happening in our body. This produced heat is dissipated from deeper organs, such as the liver and brain, to the outer parts, such as the skin, through the movement of blood. Under the first layer of skin, the epidermis, lies a network of capillaries. These capillaries allow heat produced by the body to be released into the air. Without the heart beating, blood cannot distribute heat and regulate body temperature. This leads to the body temperature reaching equilibrium with the external temperature. If the temperature is less than 37 degrees Celsius outside in the first hour after death, then the temperature of the body will decrease by 2 degrees and then continue to decrease by 1 degree every hour. Algor mortis is not an accurate way to back calculate the time of death, however, as it varies based on external conditions, such as weather, and is affected by whether the corpse was wearing clothes or not. The third sign,
All right.
rigor mortis.
Back up a little bit. So what you want to say about this one is we're measuring body temperature. Okay. So because the blood has stopped circulating, the body temperature will drop. Now I'm going to let it go from there.
Body temperature reaching equilibrium with the external temperature. If the temperature is less than 37 degrees Celsius outside in the first hour after death, then the temperature of the body will decrease by 2 degrees and then continue to decrease by 1 degree every hour.
Okay, so you got that? So this is how they can tell approximate time. The body will decrease by 2 degrees at first and then by 1 degree every hour. So by the temperature of the body, they can approximate. Remember, he said at the beginning, these are approximations. Time of death. And it can be affected by, like he said, several other things. The clothes the person has on will determine whether the external temperature is going to speed up this reaction or not. Is it summertime? Is it hot outside? Is it winter? Well, the external temperature affects the internal temperature of the body. How fast is that body going to lose temperature? So it'll be different on a summer day as opposed to a winter day.
Algor mortis is not an accurate way to back calculate the time of death, however, as it varies based on external conditions, such as weather, and is affected by whether the corpse was wearing clothes or not. The third sign, rigor mortis. This sign is one of the most important signs when it comes to determining the time of death. Rigor mortis.
Okay, write down number 3, rigor mortis. Muscle contraction. And next to that, you can write muscle contraction.
Which literally means stiff death, is the contraction of the muscles in the body after death. Before rigor mortis, all the muscles relax in a step called primary flaccidity. This happens because, after death, brain activity decreases until it completely stops. Without the brain giving muscles a signal to contract, the muscles remain in a relaxed state. Primary flaccidity lasts for 1 to 2 hours after death. The first muscles to relax are those in the eyelids, fingers, and toes. In this stage, The corpse usually releases urine and gas, as muscles controlling urination and passing gas are relaxed. Primary flaccidity is followed by rigor mortis. Muscles stiffen up in rigor mortis because of cells being broken down by digestive enzymes. This cellular breakdown is a normal part of body decomposition and is called autolysis. The breakdown of cells makes holes in the boundary of the cell and its compartments. This releases calcium ions from the separate compartment within the cell where they are stored. This calcium is crucial for initiating contraction. During normal living conditions, a signal from the nervous system triggers the calcium to release from its compartment. Another factor causing rigor mortis is the lack of ATP, the energy-giving molecule in the muscle cells. Once calcium initiates muscle contraction, myosin, a protein molecule that moves things around in the cell, binds to actin, a long chain of proteins that form the skeleton of a cell. Once the myosin binds to actin, it uses the energy from ATP to pull the actin, making the muscle fiber shorter and shorter with each pull. Immediately after death, muscles can still produce ATP. Muscles have reserves of glucose in the form of the polysaccharide glycogen, which it breaks down in the absence of oxygen to provide ATP. This ATP is used up in muscle contraction, but the muscles also need ATP to relax. This means that the actin and myosin will remain contracted until the muscle is completely decomposed. Rigor mortis starts in the same order that primary flaccidity does, with the eyes and fingers, and slowly progresses to the rest of the body. Rigor mortis reaches its peak 12 hours post-mortem. After that, the muscles begin to relax in the same order that they began contraction. After rigor mortis comes a second cycle of relaxation called secondary flaccidity, which is due to muscle degeneration. Digestive enzymes break down the proteins in the muscles, including the muscle contracting machinery. Forensic experts use this progression of muscle relaxation and stiffening to estimate the time of death. They will check to see which parts of the body have stiffened and make an estimate based on what they find.
Okay. So what you might want to write with this is there are 2 stages to rigor mortis: primary and secondary flaccidity. And then you can add down a conclusion that the scientists will look to see which stage of rigor mortis the muscles are in to determine time of death. I notice that this one takes a long time, up to 12 hours.
It is more reliable than algor mortis, as it isn't as affected by external conditions. The fourth sign, livor mortis. After death, blood is subject to the forces of gravity, now that the heart isn't moving it around any longer. It pools wherever the forces of gravity is. This starts about 15 to 30 minutes after death and starts to become visible 2 hours after death. Lividity, as it is called, starts to become fixed after 6 hours as the blood vessels begin to break down. After 8 to 12 hours, a purple coloration develops. This purple color develops because the deoxygenation of hemoglobin forms deoxyhemoglobin, which has a purple-blue color. Livor mortis can be very useful for determining time of death. Once lividity is fixed, it doesn't fade, even when the body is moved. If a part of the body came in contact with a firm surface that obstructs the blood flow, an impression of it will show on the skin that is surrounded by pooled blood. The color or pattern of lividity can allow forensic scientists to guess not only what the time of death could be, but also the cause of death. Lividity in the extremities, such as the fingers, would suggest that the body was upright, as opposed to lividity developed on the back, which would suggest a horizontal position. These 4 signs are commonly used together in order to estimate the time of death.
All right, I didn't really pause it for the last ones, but you want to make sure that you have a note for livor mortis.
The time of death is not 100% accurate, however, because of so many other factors, such as the environment, weather, clothes, or whether the victim was moved. Forensic experts will most likely give a time frame rather than an exact time. So, the next time you're watching a crime drama, don't forget to be that guy and point out all the loopholes you see.
Okay. Alrighty. So we want to get back to, so hopefully you wrote down some good notes on that. And again, I've uploaded this one to the YouTube page for Forensic Science. So if you need to watch it again, it'll be there if you didn't get all the notes that you should have. So let's look at our Canvas page. Okay, so there's some, you got a lot of science out of that. They talked a lot about ATP. Everybody remember talking about ATP before that? ATP is the energy molecule that you make during cellular respiration. And so how much energy is in the body? All right, look at this one. Did you know the rigor mortis can settle in the tiny muscles and hair follicles known as erector pili? The corpse will appear to have goosebumps. See, okay, all of these are did you know kind of things. So check those out. Cold climates will begin as soon as 1 hour after death. So that was mentioned in the video. All right, we're going to come down to alga mortis. All right, so let's look at these flip cards. So the medical examiner uses a Glaser equation, and this is the equation. How are they going to calculate? Oh, and by the way, I think in the video they used the specific temperature, and I can't get this to highlight that. But write the Glaser equation, and then write the equation. 98 degrees minus the rectal temperature at Fahrenheit. So 98 degrees is Fahrenheit divided by 1.5. So 98 degrees is what your body temperature, normal body temperature should be in Fahrenheit. It's 37 degrees Celsius. And then they do a rectal temperature, something that they hadn't done since you were a baby. And they subtract the rectal temperature of the corpse from 98 from normal body temperature and then divide it by 1.5. And that is the Glaser equation. Okay, so write that down. Question is, what is the Glaser equation? How do we calculate death using the Glaser equation? All right. So they give you an example on this card. If we have 98 degrees, 0.4, because everything is not always exact, and we subtract it by the rectal temperature, and then we divide it by 1.5. It'll give you 3 hours. So the estimated time of death would be about 3.5 hours. And they've converted it to minutes. All right, the next one. All right, so what they're asking you to do is they're giving you another situation. The body temperature was taken rectally, and it is the same temperature as the outside temperature, which is 42 degrees. So remember in the video, they said sometimes the external temperature will affect how fast the body cools down. All right, the glazier is only useful to calculate the time of death if ambient temperature has not been reached. So once the body temperature is equal to the ambient temperature, it is impossible to tell the time of death. Okay, so outside temperature makes a difference. You can't use this formula. All right, third one. The medical examiner uses the equation to estimate the time of death of a victim to be approximately 8 hours before he performed the exam. If the temperature of the victim rectally was determined as 86.8 degrees Fahrenheit, is this consistent with the determination of time of death? So in other words, they're asking you to do the equation backwards. You already know what you've determined it's 8 hours and you know what the rectal temperature is. Put this information into the formula and see if it's the same. And when you put it into the equation, it gives you kind of roughly 7.8. So it's estimated. It's about the same. Okay. All right. So you need to know what we mean by ambient temperature. What is the temperature outside? The surface of the body is laying on. Is it conductive to or trapping heat? In other words, like he said, if do you have a lot of clothing on? Are they on a cool surface, a warm surface? All of those things will determine how fast the body loses its body temperature. Diseases or drugs that may have raised the body temperature before or after death. And they would have to determine that by doing some testing. So what they would do with that information is to calculate how accurate is their Glaser equation based on the fact that it might have been affected by some disease or drugs that the victim might have taken. All right, any questions about that before we go on to the next one? All right. If you haven't read this page, take a few minutes to read this page and then go through this activity. Like I said, I know this is kind of a lot first thing in the morning. So stages of decomposition also are a telltale sign. So what we looked at before was roughly within 24. Oh my gosh, somebody just joining us. They just woke up. All right. So 12 to 24 hours, we're talking about all the four mortises. Now, past that, the body's going to start to decay. And again, the point to remember is temperature outside is a big determining factor. The body decomposes more slowly in cold weather conditions and much more quickly in hot temperatures. All right, so this one is saying this pig has died, it's fresh. All right, it's going to start to bloat because the gases are going to start to forming inside the body. And then you have active decay where the bacteria have started to break it down until you get. So one of the other things that the forensic anthropologist is going to be looking at is how much flesh is still on the bone. Have we reached all the way to the bone, or how much flesh is actually still on the bone? Okay. Oh, so take a minute to read that. I don't want to read it to you. Give you a few minutes to read that. And know who Augustus Grenville is. Okay, so we're real close to the University of Tennessee, and they are famous for having their body farm. Okay, hopefully you have your Canvas page up and you're not just looking at mine, because I'm going to go ahead and make sure that the next page is published. So when you finish reading that, go on to read about defensive wounds. Okay, I'm sending you a link to an article that I want you to look at. There are, share. So I want you to take notes on this article using the headings. All right, so and then don't start with the first one. I want you to start with 2, 3, 4, and 5. Okay. and just jot down some notes. So the first part is just a lot of vocabulary, so do read that. But then I want you to take notes on what are offensive wounds, then notes there. Why offensive wounds are harder to interpret. Come back up here to the okay. So using these 2, 3, 4, and 5 as your headings for notes, read this article and jot down some notes from what you read. Look at the pictures. The website is blocked. All right, give me 1 second. While I send out a message, see if I can do this. All right, for now, because we don't have a lot of time. So for now, let's do this while I'm sharing. So let me go back and do it like that. All right, so let's look at the vocabulary first. All right, let's start with the chart because I didn't want you to write that, but know the difference between a defensive wound and an offensive wound. So just copy that chart. And let me see if why are people just now coming to class? Yeah, I know it's still blocked, but you're looking at my screen. So look at my shared screen and just take the information from the shared screen. Okay. And I'm going to work on, let's just work on just this section right here for now. And then I'll work on getting the rest of it unblocked for next class. All right, so for right now, just copy this chart. So it's a comparison of defensive and offensive wounds. Nice of you to join us, Alyssa. We are copying the chart that's on the screen. I notice they're using two different words here, victim and assailant. So assailant is the person that we believe is causing the wound. But if there's a struggle, they will have some telltale signs as well. So a lot of time, if you're watching these crime scenes, they're looking to see if the person's arm is hurt, if their shoulder, when they touch the shoulder, do they flinch? Like, as I watch a lot of these crime shows, so I find them fascinating, but they do little things like that. If they know the person might have had an injury to the leg, they might walk by and touch their leg and watch to see if the person flinches. They look at the palms of their hands to see if they have markings on them, in addition to looking at the victim. Okay, now let's just let this be the last thing we do today since time is running out. So once you get this chart completed, you're good for today. Also, make sure that your If My Bones Could Talk essay has also been submitted.